Okay, so today's question is find all possible stable binary arrays. So you are given a positive integers 0, 1 and the limit. So a binary array ARR is called stable if the number of occurrence of 0 in ARR is exactly equal to the given variable 0. Then the number of occurrence of 1 in ARR is exactly equal to 1, and each subarray of ARR with the size greater than the limit must contain both 0 and the 1, and we have to return the number of stable binary array. So for example, this is the 0 and the 1, and we have to find the subarrays which have same number of zeros, same number of ones, and then of course the limit means if we take any of the subarray, the number of zeros and ones would be equal. Equal means that must contain both 0 and the 1. So we can do it like this. We can suppose what does it mean by that in that particular limit size we should have both 0 and 1. That means we cannot have the consecutive elements like 0 consecutive times of the size greater than the limit and 1 consecutive to the size of the limit. Okay, so our question changes to find the arrays in which the number of occurrence of 0 is exactly equal to 0, number of occurrence of 1 is exactly equal to 1, and the no zeros or no ones is consecutive more than the limit size. Okay, so let's try to code this. We will be using recursion plus memoization. So first define the mod. Okay, and what we have to return, finally we will be start building this subarrays from the back. Okay, so we will call this we'll create a function dfs0, pass z and 1. dfs0 is nothing but the subarrays which are ending with arrays with which are ending with zeros. Then we will create a dfs1 function which will also check the input z and o. I've given here by mistakenly 1, which will take 0 and the 1. Okay, dfs of 0 this what we will do. This dfs1 creates the array which ends with 1, and finally we can simply do the mod here. It's in mod. So let's try to code this. Let's create our first function, this dfs0. dfs0 is nothing but all the arrays which end with the 0. Okay, so let's do that. Define dfs of 0. Okay, what inputs it's taking? Z and 0. The input correct names are 0 and 1. We have mentioned Z and 0. Correct that. 0, 1. Similarly 0, 1. Okay, so define dfs of 0 is Z and 0. So it means you have to create the array that ends with the 0. So suppose if z is only 0, z is the equal to 0 means there are no 0 left. So how can we create a array with ending with 0? So simply return 0. Suppose if given 1 is equal to 0. Okay, so we will simply return 1 if 0 is less than equal to limit. If 0 is less than equal to the limit, so what I told, there should not be the consecutive zeros more than the limit. Okay, so if it is less, then it contributes to one array. Okay, so we will return 1, else if it is small we will simply return 0. Now create a variable total which will keep the count of how many total valid stable arrays are, binary arrays are stable who ends with 0. So simply go for key in range key from 1 to minimum of limit, whichever the minimum limit, or z, whichever minimum plus 1. Okay, so yeah, so total plus will be equal to, we are going k from either to the, from suppose limit is equal to 2, so we can go 0, 1 and 2. We can't go more than that. We can't add more 0 at the back because that will have more consecutive zeros and given conditions will fail. So we will, if suppose for example take this, we have put we have want to only this. Okay, suppose this. Okay, now our value is ending with 0. We want only one 0 at the last, suppose. So the rest of the part start with the 1. Okay, rest of the part means ends with the 1. So what we will do, this total plus will call dfs1 because 0 has been already added. So now it will call the array which is ending with the 1. So dfs1, and how many 0 we will be left? Z minus k, of course, because this k is the variable. It can be 1 to up to the limit. Z minus k, yeah. So dfs and 1 will be same. We are just decrementing the 0 count. And finally you can return here total mod plus mod. Yeah, now let's create our function which creates arrays that ends with 1. So dfs1 zeros and ones. Okay, so suppose if 1 is equal to this, similarly how we did for the 0, same thing. If 1 gets 0, we can simply return 0. We can't have more consecutive ones than the limit itself. Okay, and now suppose if 0 gets equal to 0, then simply return 1. If 1 is less than equal to limit, and if it's greater than, then simply return 0. In same case, define a variable total, initialize it with 0, and then again create a loop for k in range 1 to minimum of limit, comma, this time we are dealing with 1, so 1 plus 1. Again simply add the arrays count, so total plus is equal to, this time ending with ones. So in the consecutive ending with ones ends means it has 0 at the last, so we will call the dfs 0 for zeros count will be same, ones count will decrement by k times. Okay, and finally we can return total percent mod. And now what we will do, we will be using memoization to don't calculate the same thing again and again. Okay, so for that let's import lru cache. So for func tools simply import lru cache as it as a decorator above the functions. So at the rate lru cache, this will just do the memoization for the given function. Okay, and again same here, you can do this manually also, no need of using lru cache, but we have this function, so better use that. lru cache none. Okay, and now I think our code is good to run. Let's run and check if this works. Okay, yeah, so test cases has passed. Let's try to submit and check if this works. Yeah, so our code has passed successfully. Thank you for watching.